28. A 3 times 10 to the negative ninth Coulomb test charge is placed near a negatively charged metal sphere. The sphere exerts an electrostatic force of magnitude 6 times 10 to the negative fifth newtons on the test charge. What is the magnitude and direction of the electric field strength at this location? Okay, what's going on in this problem? Let's draw a picture. So we have a test charge being placed next to a charged metal sphere. So the metal sphere is causing there to be an electric field and the test charge being placed near it. So let's start with the sphere. So here's a sphere, and this thing is charged with 6 times 10 to the negative fifth. No, actually that's the force that it's exerting. So we don't know how this thing is charged. We just know that it has this magnetic field around it. What we do know is that a test charge, a positive test charge in fact, has been placed over here, and this guy has a charge of, and I'm using Q because that's the symbol for charge, 3 times 10 to the negative ninth coulombs. And this is that sphere, and we know it's negatively charged. Right? It says the sphere, it says it's being placed near a negatively charged metal sphere. So that's how we knew it was negatively charged. So what's going to happen here is if this thing is going to exert a force on this test charge, what direction is it going to act in? Well, opposites attract, right? So it's going to pull this guy toward it. And what force is it pulling with? It says right here it's pulling with electrostatic force of 6 times 10 to the negative 5 newtons. That's how hard it's pulling on the test charge. What's the magnitude and direction of the electric field strength at this location? So when this positive test charge is as far away as it is from that negatively charged sphere, that's the force that acts on it. And we can calculate what the field strength is at that location based on what we've been given. There's a formula in your sheet which you will find for E. E is magnetic field strength, and it's equal to the electrostatic force that's being exerted on a test charge and the magnitude of that test charge. It's divided by the magnitude of the test charge. So really all we got to do is plug these two things in. We have 6 times 10 to the negative fifth newtons, and that's being divided by 3 times 10 to the negative ninth coulombs. And 6 divided by 3 is 2, and 10 to the negative fifth divided by 10 to the negative ninth is 10 to the fourth. And the units are newtons per coulomb. So newtons are force, coulombs is charge. So the reason it describes a field strength is because the field has a magnitude of so many newtons per coulomb. So it exerts force on this charge based on how strong it is and based on the strength of how charged that test charge is. So that's basically all we need to find the magnitude of the field. Oh, and the best choice is 2 because it's 2 times 10 to the fourth newtons per coulomb toward the sphere. We said opposites attract, so it's going to pull it in.